Indices involving equations. We're going to look at case A, simple linear cases. So in this video, we're going to treat cases where indices become, or cases where the resulting indices of a given problem become an equation. So these equations are sometimes in different categories. So this particular video, I'm going to treat the simple linear cases. The other cases are simultaneous linear cases and quadratic cases. So follow through the series of videos I'm going to create on indices. Right, let's begin. And we'll solve the equation 2 raised to the power 7 equal to 8 raised to 5 minus x. So this will give us 2 raised to 7. 8 is 2 raised to the power 3, 5 minus x. So now when it comes to equation, simple linear cases, when it comes to equation, indices becoming or forming an equation, we work with something in principle. So we always equate base to base or power to power. So if the base A is equal to x and base A is equal to y plus n, since the bases are the same, they are equal, then we work to get the value of either n or x or y. Since the bases are the same, we simply take x equal to y plus n. Then we solve from here to get any of the values. Then in another case, let's say this is a raised to the power x and y equals to y plus 2 is equal to x. Now, if the powers are the same, then we can equate a equal to y plus 2, a equal to y plus 2. Then we solve for either a or y, depending on what is given to us. So in cases where indices form equation, we must work, or we must look out for bases that are the same or powers that are the same. So in this particular case, the bases are the same. 2 is equal to 2 here, 2 here, so 2 is equal to 2. So there's equating bases. We have 7 is equal to 3, 5 minus x. So 7 is equal to 3 times 5, 15 minus 3x. So this is just 7 minus 15 is equal to minus 3x. Minus 8 is equal to minus 3x. And x is equal to minus 8 over minus 3. Minus cancel minus, and this will give us 8 over 3 as our final. So then if we want to get it reduced to the simplest form, it will form a mixed fraction. And that will give us 2 over 1 over 3. 3 times 2, 6 plus 1, 7. 2 over 3. 2 over 2 over 3 as a final answer. And number 2. If 27 x raised to minus 2 is equal to 729, find x. So 27, we can get 27 in the basic form as 3 raised to the power 3, 3 raised to the power 3, and that will be x minus 2. So let's also get 729 to the basic form. So that means since it's equation, we want both bases to be the same. So that let's get the value of 729 in base 3. So let's say to get that, I'm going to divide 729 all through by 3. So 3 into 7 will give me 2. Remember 1. Bring it here, it becomes 12. 3 into 12 is 4. 3 into 9 will give me 3. 3 into 24 is 8. 3 into 3 is 1. 3 into 81 is 27. 3 into 27 is 9. 3 into 9 is 3. 3 into 3 is 1. So this will give me 3 times 3 times 3 times 3 times 3 times 3 will give me 729. So this is 3 raised to 3 multiplied itself repeatedly. 1, 2, 3, 4, 5, 6, 6 times to give us 729. So I'm going to say 3 raised to the power 6 So since the bases are the same, we should equating bases, equating the base, or equating the base, where you have so the base, we equated the base. So this base equal to this base. That will give us so 3x minus 2 is equal to 6 also. So if this base is equal to this base, that means this power is also equal to this power. So we are going to work with the power since the bases are the same. So 3 times x will give us 3x minus 6, and this will give us 6. 3x equal to 6 plus 6. 3x equal to 12. And then finish it off here. Now 3x is equal to 12. X equals 12 divided by 3. 3 here, 1, 2 here, 4. X equal to 4. That's your answer. Number 3. If 3 1 over y is equal to 1 over 27 raised to 2 over 3. Find y. So you can simplify this. 3 1 over y is equal to 3 raised to minus 1 2 over 3. So equating the bases. Equating the bases. We have 1 over y is equal to minus, and the whole can still give us minus 2 over 3. So 1 over y is equal to minus 2 over 3. Cross multiply. So minus 2y is equal to 3, and y is equal to minus 2 over 2, which is equal to minus 1 over 1 over 2. Number 4. Solve the equation 3 raised to 2 x minus 1 equal to 1 over 27 x. 3 raised to 2x minus 1 is equal to 3 raised to minus 3 raised to x. And this will give us, okay, let me just start off by saying that 27 raised to minus 1. So this part here is the same as this part. So come down here to 3 raised to 2x minus 1. So now I'm going to write this in index notation. 3 raised to minus 3 raised to x. Okay, 3 raised to 2x minus 1 equal to 3 raised to minus 3x. So equating bases. Come over here. 3 raised to 2. So 2x minus 1 is equal to minus 3x. So 2x plus 3x equal to plus 1. 5x equal to 1. X equal to 1 over 5. Number 5 is to x minus 3 over 125. 3x minus 4 is equal to 1. So this will give us 5, and so okay, 5 x raised to minus 3. 1 to 5 is 5 raised to power 3 raised to 3x minus 4. 1 is equal to 5 raised to power 0. So this will give us 5x minus 3 divided by 5 raised to 3 raised to 3 raised to 3x minus 4 to 5 raised to 7. So here on this side we're going to subtract x minus 3 minus 3 minus 3x minus 4 equal to 5 is about 0. So it's equating equating bases. The bases are the same, so the power also will be the same, or will be equal. Rather, bases are equal, so the powers are also equal. X minus 3 minus 3, 3x minus 4 equals to 0. So x minus 3 minus 3 times 3 has to give us minus 9x minus 3 times minus 4 plus 12 equals to 0. So x minus 9x, x minus 9x minus 3 plus 12 to give us plus 9 equals to 0. So minus 8 x equals to minus 9, and x equals to minus 9 over minus 8. So cancel, and that will be 9 over 8. So therefore x equal to 9 over 8, or if you reduce it, it will be equal to, or it is also equal to 1 over 1 over 8. Number 6, 4 raised to 2x over 2 is equal to 8 raised to the power x over 4. Now 2 raised to 2x over 2, and this will give us 8 raised to the power x, and so 4, 2 raised to the power 2. So this 2 will cancel this 2. 2 raised to 2x is equal to 8 is 2 raised to the power 3, then x, and then we have 1 over 2 over 2 raised to the power 2. 2 raised to 2x equals to 3x times 1 will give us 3. 2 raised to 3x over 2. Now this will give us divided by 2 raised to 2 raised to right, so divided by 2 raised to 2. So 2 raised to 2x equal to, okay, 2 raised to power 2. 2 raised to 2x equals to 2 raised to 3x over 2 minus 2. Since the bases are equal or the same, we say equating bases 2x equals to 3x over 2 minus 2. So since we have subtraction on this part of the equation, this is subtraction of fractions. So we're going to simplify this part. This gives us 2x equals to LCM of 2. 2 and 1 is 2. 2 divided by 2 is 3x minus 2 divided by 2. 2 divided by 1 rather is 2. 2 times 2, 4. So it's 2x equal to 3x minus 4 divided by 2 over 1. So we cross multiply. So when we cross multiply 2 is what I mean. This one multiply this, and this 2 multiply this. This gives 2x equals to 1, 3x minus 4. So 2 times 2x will give us 4x. 1 times 3x will give us 3x. 1 times minus 4 will give us minus 4. Next, we're going to call it like terms. 4x minus 3x is minus 4. 4x minus 3x is equal to x. So that will give us minus 4 as the final answer. Answer 4 over 3 n plus 2, 9 over 16. Okay. So we need to find the value of n. 4 over 3 is already in the basic form, so we're going to have 4 over 3 n plus 2. This will give us 3 over 4 raised to the power 2. For us to be able to work with this, the bases are not in the same order. This 4 over 3 and this 3 over 4. So remember, from x over y raised to the power n equal to y over x raised to the power minus n. So this will give us, so what we're going to do is that we're going to convert this form to this form. So we're going to have 4 over 3 n plus 2 equal to 4 over 3 minus 2. So it's this form that gave rise to this form. So therefore now the bases are equal. So equating, okay, so now that is since bases are equal, so m plus 2 is equal to, that means the powers are also equal, minus 2. So m is equal to minus 2 minus 2, and m is equal to minus 4. Alright, 2 raised to the power n is equal to 128. Find the value of 2 n raised to n minus 1, 5 raised to n minus 2. So first of all, we need to get the value of n. To get the value of n, either the power must be equal or the base must be equal. So now this is n raised to n, and without n here, so the power cannot be equal. So which means the base must be equal for this equation to be true. So for us to do that, let's find the 128 in index notation where 2 is the base. To do that, I want to divide 128 through by 2. 128 2. 2 into 128 is 6, 2 into 12 is 6, 4, 2 into 64 is 32, 2 into 32 is 16, 2 into 16 is 8, 2 into 8 is 4, 2 into 4 is 2, 2 into 2 is 1, so 1, 2, 3, 4, 5, 6, 7. So 2 raised to the power n is equal to 2 raised to the power 7, and this will give us, since the bases are equal, and the powers are also equal, so n is equal to 7. Therefore, since n is 7, since n is equal to 7, then 2n, then 2n raised to minus 1, and 5n raised to n raised to minus 2 is equal to 2, 7 minus 1, and 5, 7 minus 2. And this will give us 2 raised to the power 6, and this will give us 5 raised to the power 5. So 2 raised to the power 6 will give us, our calculator, 64. 5 raised to the power 5, 3125. And when we multiply 3125 by 64, we're going to have 200,000. And when you can express this in standard form by saying this is 2.0 times 10 raised to 5, or we can solve this way, or we say 2 raised to the power 6 and 5 raised to the power 5 to give us 2, bring 2 out, and 2 raised to the power 5 and 5 raised to the power 5. Okay, so the reason for this is that we want the powers to be the same, 5, 5. So since the powers are the same, we can say this is equal to 2 times 5 raised to, then factor the power out. So since the powers are the same, we factor the power, one of the power, we factor it out, so the factor is 5. So now this will give us 2 times 5, 10, and it will give us 2 times 2, 10 raised to the power 5. So it's the same thing. So if you open this bracket, that's 2 times 10 raised to the power 5, you're going to have 2.0 times 10 raised to the 5, still the same thing, 2 times 10 raised to the 5, and that will give you 200,000. Number 2, 1 minus y times 2, y minus 1 y minus 1 over 2 y plus 2. 8 2 minus 3y. 2 y minus y times 2 y minus 1 divided by 2 y plus 2 is equal to 8 is 2 raised to the power 3, 2 minus 3y. So here will give us 2, 1 minus y. This multiplication, so these two bases, this one multiplies this, so we're going to add plus y minus 1. This subtraction, so we're going to subtract minus y plus 2. And here it was 2, 3, 2 minus 3y. So since the bases are the same, we're going to equate, which means that bases are equal. Equating bases, we're going to have 1 minus y plus y minus 1 minus x y will give us, minus y plus 2 equal to 2 minus 3y. So 1 minus y plus y minus 1 minus x plus y will give us 1 minus y minus x plus 2 minus 2 equal to 3 times 2 is 6. 3 times minus 3y minus 9y. Minus y plus y will give us 0. 1 plus 1 minus 1 will cancel, also give us 0. So 1 minus 1 minus y minus 2. This will cancel. This will be 6 minus 9y. So minus y minus 2 is equal to 6 minus 9y minus y plus 9y plus 9y is equal to 6. This will come to this side to give us plus 2. Minus y plus 9y will give us 8y. 6 plus 2 will give us 8. So y is equal to 8 over 8. 8 and 1, 8 and 1. And 1 divided by 1 is equal to 1. Therefore, y is equal to 1. Number 3. 8 2 over x is equal to 2 3 over 8 times 4 3 over 4. Find x. 8 is 2 raised to the power 3 plus 2 over x. 2 3 over 8 times 4 plus 2 raised to the power 2. 2 over 4. So this will give us 2 plus 3 and so 2 over x equal to 2 3 over 8 plus 2 times 3 is 6, right, gives us plus, and so plus 6 over 4 is equal to 3 over 2 plus 3 over 2, and now give us 3 times 2 is 6. 3 times 2 is 6, that's 2, 6 over x equal to 2, 3 over 8 plus 3 over 2. So equating bases 6 over x is equal to 3 over 8 plus 3 over 2. So let's simplify this part. 6 over x, LCM of 8 and 2 will give us LCM of 8 and 2. That will give us 8. 8 into 8 will give us 1, that is 3. 1 times 3 is 3. 8 into 2 is 4. 4 times 3 is 12. So 6 over 8. 6 over x is equal to 15 over 8. Next is cross multiplication, to cross multiply. So 8 times 6 will give us 8 times 6 is 48, and then x times 15, 15x, and x is equal to 48 over 15. Number 4. 827x is equal to 9y. find x over y. So to find the value of x over y, 27 is 2 raised to the power 2 x, 9 is 2 raised to the power 2 y. So since the bases are equal, we'll say equating bases, we have to read x equal to 2y. But we want to have x over y, not 3x equal to 2y. So to do that, we're going to eliminate y from here. Divide both sides. Both sides by y. So this is a 3x over y equal to 2y over y. Y here 1, y here 1. So 3x over y is equal to 2. We don't want 3 here because we want our final result to be x over y. So to do that, we need to eliminate 3 from here. So divide both sides by 3. So 3x over 3y is equal to 2 over 3. 3 and 1, 3 and 1. So x over y is equal to, therefore x over y is equal to 2 over 3. 2 over 3. Number 5. Solve the equation 16 times 8 raised to the power x is equal to 32 times 4 raised to 2x minus 1. So 16 is 2 raised to the power 4 and times 8 is 2 raised to the power 2 x. 32 is 2 raised to the power 5 times 2 raised to the power 2 2x minus 1. So here 2, this multiplication will be 4. 3 times x is 3x. And here 2, 5, this multiplication plus 2 raised to 2x minus 1. So equating bases, we have 4 plus 2x equals to 5 plus 2, 2x minus 1. Now 4 plus 2x equals to 5 plus 2 times 2x, 4x, 2 times minus 1 minus 2. Now collect like terms. 4 minus 5 plus 2 is equal to 4x minus 3x. 4 minus 5 is minus 1. Minus 1 plus 2 is 1. 4x minus 3x is x. Therefore, x is equal to 1. Number 6. If 4 raised to the power n is equal to 1 over 64, find the value of 2n squared. So 4, 2 raised to the power 2, and that's 4 raised to the power n. 2 raised to the power 2 is square root of 4. And now here we have 64. And here 64, 1 raised to 2 raised to the power 6. So this is equal to 2. Raised to 2 times n is equal to 2n equal to 2 raised to minus 6. And so equating bases, 2n is equal to minus 6. And then n is equal to minus 6 over 2. So n is equal to minus 3. And this on the final side because the question says find the value of 2n squared. So say therefore 2n squared is equal to 2. Where you have n, put minus 3 raised to the power 2. 2. Minus 3 raised to the power 2 is equal to 9. So that was 2 times 9. And 2 times 9 is equal to 18. So that's the final answer. Number 7. Find n in the equation 36 times 6 raised to the power n equals to 6 times 216 raised to n minus 1. So our base, the simplest number here is 6, or the lowest number is 6. And so we have 6 and we have 6 here. 36. So this suggests that 36 must be the simplest base or the lowest form possible. So now we got 6 raised to the power 2 times 6 raised to minus 1 n multiplied by n is equal to 6 raised to 1 times. So let's find out 216 in index form, where 6 would be the base. As we're going to divide through by 6. 6 into 21 will give me 3. Remember 3. That 3 is joined to 6 becomes 36. 6 into 36 is 6. 6 into 36 is 6. 6 into 6 is 1. So this is 6 times 6 raised to the power 3. So here is 6 raised to the power 3 and raised to minus 1. Raised to n minus 1. So since this multiplication here, this got 6 raised to 2 plus, and here's 10 times 6 raised to minus n. So minus 1 times n gives us minus n. And here we have 6 raised to 1 times 6 raised to the power 3. 6 raised to the power 3 and minus 1 and minus 1. So this multiplication, and that means it's going to be 2 plus minus n. Here's also multiplication, that is 1 plus 3 and minus 1. So equating this is 2 plus minus n equals to 1 plus 3 and minus 1. Plus times minus gives us minus 2 minus n equals to 1 plus 3 times n, 3n plus 3 times minus 1 gives us minus 3. So we'll collect like terms. 2 minus 1 plus 3 is equal to 3n plus n. 2 minus 1 is equal to 1. 1 plus 3 is equal to 4. 3n plus n gives us 4n. Therefore, n is equal to 4 divided by 4. That's equal to 1. Therefore, n is equal to 1.